Okay, with what we've known based on the slope of a line being the tangent of the angle made by the positive x-axis, we can now get where the line is. You can at least know whether the slope is either positive or negative or zero. So with that, we have the first one. We have if a line, the first aspect of this, any line that slants this way, the slope is always positive. M is always positive. Why? Because at least if you notice the angle here, the angle here is less than 90, so the tangent of the angle will always be positive. But this saying that tan theta is positive because theta is less than 90. So but for this, the slope is M is negative, because assuming we have this is our notice that the angle here, theta is greater than, from here theta is between, at least is greater than 90 but less than 1/8. So the tan of theta will be negative, second quadrant. That's why the answer is negative. So any line of this form, the slope is always positive, but the line like this, the slope is negative. And also the third one is the horizontal line. M is 0. For horizontal line, 0, because tan 0 is 0. There is no angle, tan 0 is 0. So why for vertical line? For vertical line, the slope is undefined or infinite, because if this is our axis, our x-axis, you notice that this is 90, the angle is 90, so tan 90 is undefined or infinite, undefined. So M is infinity. So this is horizontal, while this is vertical line. So that's why they said slope is restricted to only slant line, because 0, nothing. This is not a number. This is not a number. But this at least must be a number positive, and this must be a number negative. That's why they say the slope of a line is restricted for only slant line. So the next one is now equation of a line. Equation of a line. Under equation of a line, we'll be looking at the first one, which is slope intercept form. The second one, double intercept form. The third one, point slope form, and the last one, 2 points form. So the slope intercept form is the easiest one. It's given the slope of a line is given y equals ms plus c. So this is the slope intercept form of equation of a line, where c is the y-intercept, and my m is the slope or gradient. So that's it. So if someone asks you to find, the equation of a line, with y-intercepts 5 units and slope, and slope 6. So without wasting time, the answer is just y equals, what's the slope? 6x plus 5. So that's our answer. So whenever you are given anything of this form, you now use this one. This is the first one. Why the second one? It's called the double intercept. The double intercept, from the name, the double intercept. So it just is of this form: x over a plus y over b equal to 1, where a is the x-intercept and b is the y-intercept. So that's what the equation states. So if someone asks you, example, find the equation of a line with x and y intercepts 4 and 5 respectively. So we're asked to find the equation of a line with x and y intercepts 4 and 5 respectively. The equation is just x over, for x is 4, for y is 5, equal to 1. Though you can still reduce further. You can reduce further by multiplying, that's removing the denominators, multiplying by their LCM. The LCM of 4 and 5 is 20, so 20 times that is 5x plus 4y equals 20. So if you don't leave it this way, depending on the option. So the next one is the point slope form. The point slope form. From the name, we are given a point and we are given the slope. So it's given as y minus y1 equals m times x minus x1, where the point is, where the given point is s1 y1. So this is our given point. Ym is slope. Remember, our m is slope. So example, now if you're asked to find the equation of a line passing through 2, 3 and pass it through and with slope 5. So we are given this and we're asked to find the equation of the line. You don't need to waste your time. The equation is what? Our x1, y1 is this. So this is our x1, y1. This is our slope. So we are using the formula now. The equation is now y minus, what is our y1? 3. Equals slope, which is 5. X minus x1 is what? 2. So that's the equation. We now simplify further. Is y minus 3 equals 5x minus 10. So this is y minus 5x equals minus 7. That's the answer. So that's our point slope form. So just note the formulas. The next one is now 2-point form. 2-point form is just almost the same thing as point slope, because we are not given the slope, but we are now given 2 points, and we know with 2 points we can get the slope. Are you following? So I'm saying that if you are given point x1, let's call A, and point x2, y2. So the equation of the line now, is now, you just choose any of the point as the point, because it must pass through 2 points. So choose any one. So it's either x, if I'm choosing A now, so it will pass through A. I'm using the point slope form now. I told you this is almost the same thing with the point slope. So I'm using the first point. But we are not, the slope now, we are not giving direct slope. But from these 2 points, we can get the slope using our formula for slope, which is y2 minus y1 over x2 minus x1. Finally, x minus x1. So what I did, I used x1, y1. Or you can use the other point, which is x2, y2. But the slope is the same thing, because it's the same line. So x minus x2. I used x2, y2. So I told you this is just a point slope form, but we are not giving, instead of giving us slope, they now gave us 2 points to know whether we could remember the formula. So example, if you asked to find the equation of a line passing through A, 1,5 and 3,7. Okay, let's call this x1, y1, this x2, y2. So let's know whether we'll get the same answer if you use the 2 points. Let's check whether we'll get the same answer. So the first one, I'm using the first point now. So this is now y minus y1, which is 5, equals, our slope is 7 minus 5 over 3 minus 1, x minus 1. So this is 2 over 2, which is 1. So I have y minus 5, x minus 1. So what I have, the final answer for this is y minus x equals 5 minus 1 is 4. So that's our answer. That's our equation. Let's check whether we use the same thing here. We get, if you use different point, which is now y minus 7 equals 7 minus 5 over 3 minus 1, x minus 3. This is y minus 7. Y minus 7 equal to, this is 1, x minus 3, which is now y minus x. 7 minus 3 is 4. Do you see it? We have the same, and we got the same answer. So anyone that you use, just choose anyone. Don't solve the two together. Just choose anyone. I'm just trying to tell you that you get the same answer by using the same different point. So the next one is now the angle between 2 lines. The angle between 2 lines. So assuming we are given this, the first line, we are given a line, this. We are now giving another line, this. So let's just draw the axis. This is my This is my let's change this to black. So assuming the first one intersected this, why the second so assuming the angle this is the first line, let's call it L1. Why this is the second line, L2. Our main aim is to find the angle between, let's call it beta. Why here? Let's call here theta 1 and theta 2. Do you get? Because our main aim is to find the angle made by this line. So this is our y and this is our x. So assuming this first line made an angle theta 1, why the second one makes an angle theta 2. So from our exterior angle theorem, you notice that beta will be theta 2 minus theta 1 by exterior angle theorem. So by exterior angle theorem, theta 2 must be, that is an exterior angle, so able to subtract any of these to give the other. But we are looking for beta, so we made beta the subject of formula. So this is the first thing we have to know. So once we know the angle between the two lines, the difference is now the angle between the line. Once we know the angle made by each of the lines, the difference is now that. So again, let's introduce, because we are trying to, because our next subheading is now parallel and perpendicular line. And let's now introduce tan to both sides. Let's introduce tan to both sides. So let's introduce tan to both sides. So we are saying that tan beta is now tan theta 2 minus theta 1. And from advanced trigonometry, this is always equal to tan theta 2 minus tan theta 1 over 1 plus tan theta 2 tan theta 1. That's from advanced trigonometry. So we are saying that tan beta now is now, from this, do you remember tan theta is slope? So we have m2 minus m1 over 1 plus m2 m1. So this is now for a very good formula that will help us to get something unique. That we will now relate it to parallel and perpendicular lines. So the next one is parallel line. So the next one is parallel line. So if two lines are parallel, means that the angle between the two is 0. Two lines are parallel if the lines are the angle between the two is 0. So for parallel lines now, beta is 0. So which implies that tan 0 is now m2 minus m1 over 1 plus m2 m1. And what is tan 0? Tan 0 is 0. m2 minus m1 over 1 plus m2 m1, which implies that m2 minus m1 must be 0. Yes. Therefore, m1 must be equal to m2. So for parallel line, the slope of the lines are equal. So that's the condition for parallel line. The slope for parallel line, the slopes are equal. But for perpendicular line, but for perpendicular line, the angle between the two lines are perpendicular if the angle is 90 between us, if this is the first one. So they are perpendicular if the angle between them. So I'm saying that beta is 90 degrees. Therefore, tan 90 is now m2 minus m1 over 1 plus m2 m1. And what is tan 90? Undefined. Infinity. 1 plus m2 m1. And you know something, for something to be infinity is any constant over 0. That's the meaning. Infinity means constant over 0. m2s. But the constant will not be 0. Any other value except 0. So which implies that the denominator, because our main target, we don't know anything could be here, but we know the denominator must be 0, which implies that 0 must be equal to 1 plus m2 m1. We are comparing now. So 0 must be equal to the denominator. So m1 times m2 is equal to minus 1. So for perpendicular lines, this product of their slope is always negative 1. Meaning that you can use it to get each of them. I'm saying that, which implies therefore m1 is minus 1 over m2, and also m2 is minus 1 over m1. So this information will help us to solve a lot of questions in coordinate geometry. So let's now enter to exam. Let's now solve exam question on all these analyses I've done. Thank you.